Hello and welcome back. Today we're going to be doing something a little bit different. Not necessarily a tutorial, but more just kind of a breakdown of how I did something and a link to all of the project files so that you can implement it in your projects. I had been requested by several of my long-term subscribers to kind of use the vertex displacement, use those shader tutorials to do something that's a little bit more interesting, like environmental interactions. And honestly, I'd been doing the shader tutorials for a couple weeks and I just kind of wanted to stretch my legs and try something else. So I threw this together actually only in like one day, and then I spent a couple days actually like documenting it and cleaning it up. And I'm just going to kind of go over everything and how I got it implemented and then give it to you and let you use it for whatever you want in your projects. There is a link to the GitHub repository in the description. It has instructions in the README on how to install it and everything, and it's not too complicated. It is structured like a plugin, though it's not actually on the asset library. I probably should add that later. But for now, you just download from the GitHub repo, pull it into your add-ons folder, and then go through the steps to install it, which I'll go ahead and go through right now. In order to install it, all you have to do is go ahead and drag in the details renderer from the pack scenes, and that's going to go ahead and render the environment to the details texture, but you do need to go ahead and set up your global shader variable so it has somewhere to render to. Now, you won't see this in editor unless you've set it up, and I would suggest going ahead and setting it up just so you can actually see the environmental interactions when you're testing things, so you don't have to hit play every time. But during runtime, all this is automatically filled by the script on the details renderer. So the viewport texture is just the image output by that details renderer. Once you have it in scene, you can hit new viewport texture right here and just select the details renderer, and it'll go ahead and fill that data in. And then the corner position is half of the size off of 0. So it'd be -64 if the size is 128. Now 128 is just the region that it's actually rendering the details off of the player's position. So the larger region, obviously the better it'll look from a distance, but the size will have to go up in order to have detail for like footprints and stuff like that. Right now I just run the size at like 512 by 512. You can set it up to a higher value, but honestly, without tessellation on the terrain, you really don't need too high of resolution because there's just not enough geometry on the terrain to even reflect that. Everything else can be pretty much described in the README. I'm not going to go into too much details, but the basic gist of how it all works is kind of important. So let's say we have our player right here, and you see that green thing around them. That is the displacement of the grass. That's to make sure when you're standing on the grass folds up underneath you. And the way that is actually rendered out to this texture, and more importantly, the way that texture is then reflected onto the terrain is important. So going over to my whiteboard, imagine that the texture is just an image in the environment. And the corner of this texture is the corner that we put in the global shader variable. Now, say we have a position right here. Then in order to determine where in the image it is, we subtract it from the origin and then we divide it by the size, which in this case is 128. So by doing so, we get a 0 to 1 scale for the UVs of this position. And as a result, we can go ahead and sample the image and determine where we are and determine what is affecting that location. Red being, in my case, footsteps, green being grass manipulation, and blue being water manipulation. Now, all of these stamps are spawned out by the characters using a fairly simple script. If we go over to the basic player controller, you can see we have the different pack scenes here, and we have some code to determine when it should spawn these things out. And then just basically as we move through the world, if the velocity is more than a certain amount, we spawn footprints, and if we're below a certain value, we spawn ripples, and so on and so forth. It's not very complicated. It's just a little bit of code, and you can go over this all in your own time and look at whatever you like. Now, something important to note, I would replace all of these stamps with particles. So let me pull out a stamp real quick. And we can see we have our little footprint stamp here, and we can scale it up or scale it down, and we can see how it manipulates the environment. Right now I'm just running it as a mesh instance 3D with a shader on it and a plane, and then it has a script on it that fades it out over time using an instance shader variable. This is horribly inefficient compared to a particle system. I would highly suggest that if you are going to implement this into your project, please use a particle system. It will be much better performance. Now, that being said, this does work. I just kind of threw it together in a day, so I didn't think about it, and I just did the easiest way to implement it. And so as a result, we have this little script here. Now, that being said, we have a couple other things. We have the water waves, which when scaled up, you can see a little deformation to the environment. I did these very soft. I didn't do them too drastic. And then of course, we also have the grass trail. and the grass trail just manipulates the grass. We leave a whole bunch of these behind the player and the characters as they move around. And all of this is rendered out by the render texture and then passed on to the shader. Now, the shaders on the terrain, they all inherit from a library, and you can see that up at the top of the script. In order to use these in your shaders, you'll need to include this, and then within the shader itself, you can call the sample detail effects layer, and the output is RGB, which is whatever the color of the stamps in that location are, with A being the gradient to the edge of the stamp. So basically that image, we control a gradient right at the edges to fade everything out smoothly, so that way you don't have sharp cutoffs at the end of the stamps. And that's all controlled via the shader. So if you go over to the water mesh, for example, you can see we have these shader parameters. These are inserted because we included this library, and they just have faded edges, Boolean, and a smoothness value. And you can set that to whatever you like. Now, in order to sample this, you do need the world position. You can get that in the vertex or the fragment using two different methods. In the vertex, we're going to use the node position world plus the vertex. That gets you your world position in the vertex shader. And then down here in the fragment shader, we're using the inverse view matrix multiplied by vertex. And then we're bringing that back down to a vector 3 using the XYZ. And that's pretty much it. It's nothing too complicated. Now, important to note here, I did go ahead and create a visual shader plugin. So in order to get that data the same way as you do in the script, all you have to do is right click and add a detail effects sample. And that'll go ahead and pull your RGB as well as the alpha being the gradient on the outside. And it will also go ahead and insert these variables at the top of your shader. So hopefully this can be useful in both the normal shader and the visual shaders. There's nothing too complicated actually using them. Just imagine them like a mask, like decals essentially. You could use them for anything. You could probably use them for like ruts in the ground for roads, or you could even use them to displace around a boat as it sails through the ocean. But that's pretty much it. Using this system, and provided you optimize a little bit more than I did and use actual particles, you could probably support any number of characters and have a fairly good result. The ripples themselves are probably the location that I put the most work into, is making the water actually look good. The waves are literally just a decal with that texture, and it just pans across the waves, and then I just place them out in the world, and it's not too complicated, and nothing's too complicated. But the end result isn't half bad. You leave these little trails through the grass and everything. Is really fun. And if you look close, you can actually see I am deforming down to the grass. All that's in the terrain shader. It's a little bit more complex than I really probably should have gave it credit for, and I need to go back and optimize it. Something else, because the detail on the terrain is a little bit more than what you're actually going to get on terrain, you're never going to be able to get these vertex displacements to be quite as smooth as this without tessellation, and right now tessellation is just not available in Godot, so that's something I'm going to have to kind of combat. I'm looking into doing it with parallax mapping. We'll see what that comes to. Maybe I'll get it working, maybe I won't, but I'll probably have to get something working when I implement it in my own terrain system. But for now, that's it. I hope you all enjoyed this little vacation from all tutorials and just kind of going over a little side project and having some fun. Feel free to download it. Make sure to do those optimizations using particles as opposed to just using my little mesh instance 3D method, because it's terrible. And as always, thank you all for watching. I hope you all have a wonderful day. We'll see you all back here next week for an actual tutorial.